It will be helpful for the exam also. YouTube ಗೆ ಆಗುತ್ತಾ ಬೇರೆ use ಮಾಡಿ. Instead of that programs part ಬೇಡ, it will be another playlist. ಇದನ್ನ ನಾನು
ಸ್ವಲ್ಪ ಲೇಟ್ ಆಗುತ್ತೆ ಸರ್, ಇಲ್ಲಿ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇದೆ ಸಿಕ್ಕಾಪಟ್ಟೆ.
ನಾನು ಬ್ಲಾಗ್ ಅಲ್ಲಿ ಹಾಕಿರ್ತೀನಿ ರೀ, ಬ್ಲಾಗ್ ಅಲ್ಲಿ ಹಾಕಿರ್ತೀನಿ, ನೀವು ಟೇಕ್ ಫ್ರಮ್ ದ ಬ್ಲಾಗ್. ಓಕೆನಾ?
ಸರಿ ಸರ್ ಆಯ್ತು. ಸರಿ ಸರ್ ಆಯ್ತು, ಹಾಕ್ತೀನಿ.
Okay, we'll start the class. Time up. So till now we discussed only the 9 programs, 1 to 9 program of SS and OS lab. Whatever the lab programs, Lex and YAP programs, round robin scheduling, and then shortage of first, and then page replacement algorithms, first in first out, and then least recently used, least frequently used. Those are all the page replacement algorithms, bankers algorithm already been discussed. Come to the your module 5, syntax directed translation. Before go to the syntax directed translation, already you know the various phases of compilers. All of you seeing this notes, H1?
ಎಸ್ ಸರ್, ಕಾಣ್ತಿದೆ, ನೋಡ್ತಿದ್ದೀವಿ ಸರ್.
ಅಲ್ಲ ಈ notes clear visible?
ಎಸ್ ಸರ್, ವಿಸಿಬಲ್.
Okay, that's so module, because last class I did one notes. I told you know that no I shared, but it's not displayed. Something problem. Okay, we come to the syntax directed definition. So this syntax directed translation. Already the various phases of compilers we know, where lexical analysis, syntax analysis, and then the semantic analysis. Lexical part already been discussed, and then syntactic part that also been discussed. Next come to the semantic. So in syntax analysis, ambiguity, parsing, the drawing the parse tree, syntactic tree, success of any problem already been discussed in the module 4. So next we have a good discussion under the syntax directed translation. So very easy to follow. This is a very interesting one, very easy to follow. Don't neglect this module 5, please. It's very easy to get good marks for your exams. So syntax directed definitions. First we have a SDD. We come to the first part, SDD. Don't some noise here. Please don't do all these things. The class, after the class, we can wait for another 5 minutes for this. So syntax directed definition, SDD. Many times they're asking this question, what is syntax directed definition? So this definition here is a kind of abstract specification. Abstract in the sense from initial level specification. Here an augmented CFG. CFG means context free grammar is generated. Right mark, wherever I mention this right mark, note down. Here an augmented in the sense, S is a start symbol, S tends to S dash. T is a start symbol, T tends to T dash. So we have one augmented specifications will be there. That will be nothing but you are in SDD, augmented CFG is generated. The set of attributes are associated with the terminals and non-terminal symbols. We know the terminals, lowercase and then capital letters, single capital letters. All those things has also been there in the attributes. Attributes means some properties are associated with whatever the functions, whatever the productions we are using, consisting of both terminals and non-terminal symbols. Attribute is very, very important here. Therefore, I stress out this attribute that can be a string, that can be a number, it may be a type, it may be a memory location or anything else. See, 1, 2, 3, 4, 5 attributes. We worry about attributes throughout this chapter. We need to discuss in the level of attributes only. So that may be a string, number, type, memory location, or it may be anything else. So one diagram they are given, input string. See, first whatever the input you got, the strings, sequence of characters, that is syntactic tree structures we need to draw. So again we jump on to the dependency graph. Next, evaluation order of our semantic rules. So every time we need to understand semantic in the sense meaning of the particular equations or expressions or whatever the inputs you have been checked, that meanings we have to follow by using the dependency graph. First step, 3 steps they are given. We parse the input token. That means we already know the parse trees. How to draw the parse tree. Here also draw parse the input token stream and syntax tree is generated. You know how to generate the syntax tree. See which one is left side, which one is right side, the productions, how we're going to draw with respect to the symbols being used. That we have to draw the parse tree or syntax tree generated. Then the tree is being traversed. This is very important. Then the tree is being traversed for evaluating the semantic rules at the parse tree nodes. See, every nodes we need to parse. See, every node we need to obtain the semantic, the meaning. In every node we need to draw the semantic meaning of the parse tree node. So in single pass implementation, semantic rules can be evaluated during parsing without explicitly constructing a parse tree or dependency graph. We know in single pass, already you worry about single pass and then the pass one, pass two. So in single pass, no need to draw the parse tree and dependency graph without explicitly constructing. We need to understand the meaning. But here the nodes, here understand this one in this third point in the semantic evaluation at the nodes, every nodes of the syntactic trees, values of the attributes are defined for the given input strings. Every node we aim to obtain the values of the attributes are defined in the given input strings. That you later you can understand every node how you're going to write the values of attributes to be defined for the input given string. Such a parse tree containing all your values. See, wherever parse tree, wherever node is there, that values will be there, that values of attributes at each node. That you remember the main idea behind this SDD, syntax directed definition, values of attributes will be available at each node, is called an unnoted parse tree. Come to this definition. This definition, the 4 marks question, some question paper they're asking about the definition of the syntax directed definition. So what is this syntax directed definition? Is a generalization of CFG, obviously, in which each grammar has production x tends to alpha. Every time we need to copy this x tends to alpha. X may be non-terminal symbol, else alpha may be consisting of terminal symbols. That terminal symbols here written here is a set of semantic rules of the form A equals to f of b1, b2, b2. What is this f for? F is nothing but a function. Some function they may give where left hand side A will be an attribute and then obtained from function f. See, whatever b1, b2, b3. See, these are all nothing but your some attributes. So where A is an attribute. Function 1, that means b1. Function of b2. What is that particular function being available in the particular productions? Or it may be in the function also. The total answer is called as an attribute. That group together in the particular function from b1 to bk, that function having certain attributes, that will be keep it as in a small a. See here they written nicely, attribute can be a string, a number, a type or memory location. Consider x tends to alpha be a context free grammar, a tends to f of b1, b2, bk, where a is an attribute. Every function we have to worry about the attributes. Two types of attributes also there here. That two types of attributes we need to consider here. See, two types of, as we have synthesized attributes and then inherited attributes. Note on this one, there are two types of attributes. Synthesized, and many times they're asking the synthesized distinction between synthesized attributes and then inherited attributes. So synthesized attribute A is called synthesized attributes of X. X in the sense, just now we have discussed X in the sense that will be single capital letter, X tends to alpha. X, A is an attribute, that means it's called as a synthesized attribute of X. And D1, B2, just now we have written D1, B2, Bn up to Bk are attributes belonging to the production symbol. Just now D1, B2, Bk up to this Bk, everything will be production symbols. Productions, X tends to A, X tends to B, X tends to whatever they may give. So this B1, B2, Bk are attributes belonging to the production symbol. Totally this is called as an attribute. That is called as a synthesized attribute. A is a synthesized attributes. The value of synthesized attribute at each node, at a node in the sense every node is computed from the values of attributes at the children of that node in the parse tree. So we have a child, that means parent and children. So we have a bottom up parse tree and then top down parse tree. Same thing will be repeating here. So, but here we need to compute from the values of attributes at the children of that node in the parse tree. Every time we need to obtain the value of attributes of the children of that node in the parse tree. Children of that node in the parse tree. That you have to remember. That is nothing but your synthesized attributes. Last word underlined, whatever underlined, that because of you only. So the values of attributes of the children of the node in the parse tree, that you have to be calculated. Inherited attributes. Attribute again. Attribute is called inherited attribute of one of the grammar symbol on the right side of the production alpha. Here we need to worry about the left side of that synthesis attribute of X here, left side of the non-terminal we need to discuss in the synthesized attribute. Here we worry about the right side of the production. So that will be that is alpha. And B1 to Bk. Here also right side only we have a B1 to Bk are belonging to either X or alpha. We are completely discussed about X. So we will be under the alpha only. So this alpha, see whatever it may be, the inherited attributes can be computed from the values of the attributes at the siblings and parent of that node. See here it will be from the that means values of attributes at the siblings. Siblings in the sense the particular belongings of that particular node. So siblings and parent of that node. We need to compute the values of attributes at the siblings and parent of that node. See here only values of attributes at the children of the node in the past in the synthesizer. Remember that word children of that node in the past is synthesizer attributes. Siblings you word you remember, and then and parent of that particular node, that is nothing but inherited attribute. Here we synthesize attributes vary about capital letter X, single non-terminal symbol. According to that we follow the rule. Here we have an alpha, right hand side productions alpha and b1 b2 belonging to either X or alpha, that we need to discuss for the inherited attributes. Come to the next synthesize attribute. We'll take one example of synthesize attribute. See they are given so many example here. Not on this one. S tends to S tends to CFG, S tends to EN, E tends to E plus T. See, these are all the some grammar, context-free grammar they are given. S tends to EN, E tends to E plus T, minus T, T star F, division by T by F, F. So already you know about all these productions. See, the syntax directed definition. Just now we discussed, we need to worry about the capital X single non-terminal symbol belonging to the production symbols and children of that node in the, we need to find the values of attributes available at the children of that node in the past tree. Come to the table. Syntax directed definition can be written for this grammar by using semantic actions for each production. Whatever the question they may give, if we have to mention one table. In this table, production rule, keep it in one column. Semantic action, the meaningful of the particular production, each productions, that is in another column. Semantic action. Come to the first one. S tends to En. S tends to En. E already you know it is a S will be the start symbol. Definitely an augmented grammar will be there. So we need to store the answer in S only. So that we're going to discuss. S tends to En. N in the sense what here semicolon. It ends with a semicolon. Terminal symbols are there. So print wherever terminal symbols being found, wherever the attributes will found, wherever the lowercase letters. Just now we discussed. Wherever this d1, dk or attributes are belonging to the production symbol we found, wherever this terminal symbols being found, wherever this semicolon or any terminal symbol being found, that itself going to generate the values of attributes that we are written here dot val. So print e dot val. Here S will be the starting production start symbol. So E will be the particular productions. N ends with a, that means semicolon, that will be the terminal symbol. So we need to calculate E dot val. So S tends to S. Any doubt here? Yes, any doubt can ask. Okay, we can follow. A print E dot val. So N we have in this grammar production, N will be the semicolon. So print E dot val. So E dot val in the sense for particular attributes of values to be printed with respect to the grammar they are given. So E tends to E1 plus T. See, E1 in the sense for every augmented grammar, whenever, that's what we told in the beginning only, E tends to E plus T. Whenever one more capital letter will repeating, that will called as an augmented grammar, that is distinguished by E1. S in the sense S1. E in the sense E1. Like that we'll go into distinguish in augmented grammar. E tends to E1 plus T. E dot value equals to E1 dot val plus E dot val. Why dot val in the sense in every node, in every C, E attached with the particular val. See, that's what En here they are given. N tends to the semicolon, that will be the terminal symbol, that values of attributes we have to calculate. So printf E dot val. So again wherever E1 is there, dot val. Again T. T in the sense what happens, this T also, T to F, F to E, and then E to, that means same thing. We have F to digit is there. So E to F, F to digit in the sense that will be also val. So here also we have a T dot val. Wherever we have, just you add value, that particular value to be added to the particular production. E1 minus 2. So here also E1 dot val minus T dot val. E tends to T. Same thing. E dot val equals to T dot val. And then T dot val equals to T1 dot val star F dot val. So everywhere we have to, in every production, we need to add this value of attributes to the particular non-terminal symbol. See, go on adding. Everywhere we are going on, because T tends to S tends to E, E tends to T, T tends to F, F tends to digit. And S also we have a, and then S also we are have a, now they are under, S also we are having E N will be ends with a terminal symbol. So wherever we have, we just add this val. T dot val divided by val, T value equals to F dot val. So this is the first type of syntax directed definition, by adding the values of attributes to the particular non-terminal symbol. Digit, wherever directly they are written digit, there we need to generate a lexical value. See, lex value. See the last one. We have a last one. We have a F dot value equals to digit. You can know them. That value equals to digit dot lex val. So this is the things we need to consider. Wherever they mention digit in the production, mention F dot value equals to digit dot lex val. This can be ignored. N tends to semicolon, in the sense that can be ignored, is a terminal symbol. Directly they are given semicolon. So semicolon in the sense the end of the production, that can be ignored. That is it's a terminal symbol in there. Next, come to the, for the non-terminal symbol, wherever we found this capital E, T, and F, the values can be obtained using the attributes val. Just now we did, wherever E is there, wherever T is there, wherever F is there, the values of attributes can be obtained using the attribute val. Here val is an attribute, and semantic rule is computed by using the value. See, the val is the attribute, and semantic rule is computed the value of all val. So like that, we'll going to perform the operation. The token digit, we are considering lex val also. The digit as the token digit as synthesized attribute lex val, whose value can be obtained from lexical analysis. Wherever digit is there, obviously the synthesized attributes lex val to be add. So whose value can be obtained from lexical analyzer. So the rule extends to E, and S is a start symbol. This rule is to print the final answer of expression. That's what I've told. Whichever the symbol is the start symbol, that rule is to print the final answer of expression. Here we'll start the production is yes. There only we're going to store the final answer of expression. In STD, terminals have synthesized attributes only. So keep this information in mind. In STD, terminals have synthesized attributes only. See, that is the main idea behind the synthesized attributes. Terminals, wherever the terminals, that means the digit, the values, whatever you got, the terminal symbols only have synthesized attributes only. The synthesized attributes are often used in STD, syntax directed definition. This STD uses only synthesized attributes is called S attribute definition. What is S attributed definition? Many times they're asking. In syntax directed definition, terminals have synthesized attributes only. So that synthesized attributes are often used in STD. STD uses only the synthesized attributes is called as S attributed definition. Only synthesized attributes in the sense that has some value. That particular attributes or values being found wherever in the production, that is nothing but your S attributed definition. In a parse tree, at each node, the semantic rule is evaluated for annotating, in the sense computing the S attribute definition. In any kind of question they may ask, we need to draw the parse tree at each node. We need a parse tree. The parse tree at each node, the semantic rule is evaluated for computing the S attribute definition. Go on telling again and again. In a parse tree, each node, the semantic rule is computed the S attribute definition. The steps to compute S attribute definition, only 3 steps are there. In any problem, in any question they may give, write STD using appropriate semantic action for corresponding production rule of the given grammar. Whatever the question, to draw this syntax directed definition using appropriate semantic action. Just now we draw, whatever the semantic action for each and every production. S tends to En. E, obviously, it is a symbol, non-terminal symbol. N ends with a semicolon. So print this E dot value. Directly we can say print. Remaining all our productions, E to T, T to F. So we need to have this value of attributes of production that they are telling in the right STD using appropriate semantic action for corresponding productions rule of each given grammar. Annotated parse tree is generated. We need to draw the parse tree, annotated parse tree is generated, and attribute values are computed. The computation to be done in bottom-up manner. See, every time they are asking about which type of manner we're going to draw the parse tree. So the annotated parse tree is generated and attribute values are computed. The computation to be done in bottom-up manner. So whatever the parse tree that you draw bottom-up fashion, that you have to know from children to the parents, from siblings to the node, whatever the manner we're going to write the parse tree, that you have to be carefully to be drawn in the bottom-up manner. The value obtained at the root node is supported to be the final output. Whatever the value to be obtained at the root node in the sense here in this example, S will be the root node. Obviously, answer will be available in the root node S only. So how we'll going to obtain the value obtained at the root node is supported to be the final output, that will be discussed in this example. So just now we discussed obtained STT of the grammar. This is an examination question. They are given all the products and consider S tends to n, e plus t, e minus tt, and then t tends to star f, t by f, f, and f. So here e to t is there, t to f is there, f to digit is there, and then s to finally we got this one. Already you know this productions. In this production, they're asking to draw obtain STT for the grammar. Let values is a synthesis attributes associated with the ETF. Whatever the capital letter, single capital letter, here S will be the start symbol. Keep it away. So there only we know to show the answer. Remaining three ETF. So n already is a particular attribute. So particular value of attribute is ended with a semicolon. It's a terminal symbol. No need to worry about this. Remaining three E, T, and F. These are all non-terminal symbols. So we need to consider the semantic rules for all those things. See, whatever the single capital letter that we need to calculate here, the values of attributes for the particular one. So how S tends to N directly we can print here E dot value. Just now we return E every time we add this E1 dot L E dot value equals to T dot value. Every time we add this value of attribute, wherever digit is put, just add lexical value of that one. Just now we discussed about this lexical value. Just we need to add the particular wherever digit is found, we need to see wherever the token digit has synthesized attribute lex value. So we need to add this digit as token has a digital lex value is there. So we need to attach this lex value to a particular semantic action. Next, come to second question. They're asking construct parse tree. This is the main SDD. The main intention is to construct parse tree and give semantic actions for each node. That is the main idea behind this syntax directed definition. Construct parse tree, syntax tree, and annotated parse tree. Annotated in the sense computation of the parse tree for the input string 5 star 6 plus 7. So first syntax tree we need to the syntax tree already you know. So we have a first we have 5 plus 5 star 6 plus 7. So computation it will be BODMAS rule. According to that BODMAS rule, we have a 5 star 6 to be computed first. Take this 5 star 6. This is what is over. See, this is the particular one. 5 star 6 is got you know. Then we add with a plus 7. So that is your syntax tree. Parse tree with respect to your productions we need to draw. So first starting symbol is yes. First starting symbol is yes. So we have a S tends to En. Just now we written S tends to En. E and then N ends with what? N will be nothing but your terminated symbol. We wrote this semicolon here. E tends to E plus T. Just now written E plus T, right? E plus T, E minus T, E star T. Everything will be there available in the E. From E, we got E to T is there. So that purpose we have a T tends to T star F, E to T. So definitely E to T in the sense E tends to T star F. T star F, we have written E to T. So from this E to T, we have E tends to T star F. And then T to F, F to digit. We ends with all the symbols, finally ends with a digit. F2 digit, here also F2 digit, N ends with a semicolon. Final answer will be at the S. So annotated parse tree, your computation. See, at each node we need to show the semantic rules action. See, E dot value equals to 37. Value obtained from child to parent. See, they written, I have written value obtained from child to the parent. See, 5 star 6 30 plus 7, that to be keep it in the E dot val. Value obtained from child to parent. Yes will be the final answer to be stored in yes. So print 37. N ends, so that means I have a terminated symbol. And then wherever this in this past tree, wherever you written the single capital letter, that non-terminated symbol, you mention the values of attribute. That will be the meaning of the particular production. That will be the semantic actions of the productions. E dot value equals to 37. E dot value equals to 30. See, just now written 5 into 30 in the syntax tree. That you write it here. That star E dot value equals to 30 plus what happens? We have a T. T in the sense we have a T2 val is there. That is nothing but 7. So we are after this place we have 7 in the syntax tree. Right? This one to T dot value equals to 7. So again E to T. Already you know E to T. I have written here also E to T. T to here you note on this one E to T and then T star F and then T to F, F to I and then we go for ID. So here also E dot value equals to 30. That E to T in the Brahmer productions we have a E tends to E plus T or E minus T and then T single T is there. So we have a E to T, T to T star F. So that we have a E to T, T to T star F. T star F in the sense already you know these are all the symbols. T dot value equals to 5. See look at once into the only 10 minutes are there. Look at 1 into the syntax tree. There we have a T dot value equals to 5. F dot value equals to 6. So again we have a T to F. F in the sense F dot value same thing 5 digit here the value already given in the F. F tends to digit. So therefore F tends to digit you would add digit dot x value equals to 6. End there only. Wherever you got lexical value of the particular digit ends here. So digit dot lex value equals to 5. F2 digit is there again 5. Wherever you got this digit multiply and keep the answer. See from bottom to the root 2. See 5 digit dot lex value equals to 5. Digit dot lex value equals to 6. Multiply, keep it in the answer T dot value equals to 30. That T E to T we have final answer E dot value equals to 30. That we have to add with a plus 7. Already you got this digit dot lex 7 equals to 7. Add with the from T. T to F, F to digit. That is there in every concept T to E to T, T to F, F to digit. You maintain in every node of the past tree. Every node of the past tree we need to write the meaning. See here I am writing dot value being attached. Here I am writing digit dot lex value to be attached. At each node we need to attach the meaning or attribute definition of the node. That will be final answer to be kept in the S10 to principle. So this is the way of writing. This carries 8 marks. Writing this table, writing this syntax tree, parse tree, writing this syntax tree, parse tree, and annotated parse tree. This will going to say the definition of syntax directed definition. So I told start from leftmost bottommost node. The rule F tends to digit is used in order to reduce digit to F. Wherever F is there, digit. Wherever F is there, digit. Just only I'm going doing F10 to digit is used in every production in order to reduce digits to F. We go on did that one. The lex digit wherever this is digit dot lex value. Semantic action that takes place here will be F dot value wherever is there. Immediately we need to mention digit dot lex value. That's what I've written in the boxes. You remember these boxes. F dot value equals to digit dot lex value and then F dot value equals to the final answer is 5. Here I'm writing F dot value is 5. Here I'm writing another right hand side value will be 6. So like that we'll take that value and then multiply. And then thus the computation T is the parent node of F. That also remember T will be the parent node of F. So semantic action will be T dot value equals to F dot. See from E to T, why I'm taking in the sense, why I'm captured in the sense, T will be the parent node of F. Therefore, so semantic action suggests T dot value equals to F dot value. So T dot value equals to F dot value, both are almost same. So because of that one, we're writing T to F, T and here also they written T to F. So both are same. They written T to F. And then finally we got T dot value equals to 5. Computation with T tends to T1 star F. That's not with their given T tends to T star F. T dot value T1 dot L 30 they are given. Combination of E1 plus T that becomes C. The first time combination of E1 plus T that will be the E dot value. Finally we calculated that E dot value plus T value that becomes 37. So T1 value already we got this digit dot lex value. So I multiply both digit values here 5 and 6. We got 30 here. Keep it in T dot value. T dot value, whatever you answer you got, that is nothing but your both T and F. Already written T dot value, the F dot value, both are same, E to T. So definitely E1 will be the final answer, that is 30. But that to be added with the T dot value plus 7, it equals 37. So that T dot value will be the right hand child of E. So T dot value will be the right child. See here, T dot value will be the right child. Wherever we return this E plus T, this T will be the right child of E. So here also I have written right child of E. So E1 dot value will be the left child of E. So that purpose N will be the termination of current expression. S tends to N suggests to print resulting E dot value. Hence output is 37. Thus S attribute definition can be computed in bottom up fashion or using post order traversal. That S attribute, according to our S attribute definition, that can be computed in bottom up fashion or using post order traversal. Therefore the answers will be 37. Keep it in yes only. So S will be the start symbol. So keep the answers in yes only. Keep the answer in S only. N will be the termination symbol. E1 plus T. That will be the E1 dot val left child of E. So that also you have to remember. E to E1. Here I'm not taking E also. E1 will be the left child. T dot value will be the right child of E. In the beginning only they are written. E1, E dot value the left side. T dot value that is the right side of E. So therefore we can't able to put the answers in E dot value for 37. That value obtained from child to the parent. Therefore S tends to the particular answer, that will be print 37. Here also that S attribute definition. I told S attribute definition. Now you see that S attribute means what? In a parse tree at each node, the semantic rule is evaluated. That means in each node, just now we draw the parse tree. At each node we are mentioning dot val, digital X value. So already been each node consisting of the semantic rule for computing the S attribute definition. That S attribute definition, see the steps. So appropriate semantic action corresponding to the production rule for each grammar. Appropriate semantic action corresponding to the production rule of given grammar we have written. Annotated parse tree is generated. See, just now we draw, this is annotated parse tree. Last diagram, annotated parse tree. We need to draw, generate, and attributes values are computed. What the attributes you got, you have to be computed, and then computation is done in bottom up manner. See, every computation to be done. See, 5, next 5 to be done in the bottom of the here. After 5 only, after 6 only we got this value. Then you go from bottom to the root level. So 5 star is 30. 30 plus here also 30 from digital X. So they again with 37, then you got this 37, then finally answer will be yes. So every time this bottom up fashion, that bottom up level only going to show it is a S attribute definition. Therefore the S attribute definition can become the bottom up fashion. One more example is there. This is here they see no. Give the STD for simple desk calculator and draw annotated parse tree for the expressions. See, they're asking, weight you December 10, 16 marks 10. See, very easy to get this 10 marks. Give STD for simple desk calculator. They're given solution. You only remember all these 4 productions. See, S tends to N. Just now we discussed. E tends to E plus T R bar T. Just now we written. T star F bar F. E to T, T to F, F to E or digit. If you know all these 4 productions, then easily see everywhere we D dot value. S will be the start symbol. Therefore, answer will be available in S only. E N ends with a semicolon. Obviously, N will be the semicolon. So E dot val. And then E1 plus E will be augmented grammar. So definitely E1 will be the next production. Wherever both are same terminal symbols, put one as E1, that will be the augmented grammar. E dot val, left hand side E dot val, attach val to the each and every side of the production. E1 dot val, T dot val, E dot val equals to T dot val. Again, everywhere you add this dot value. Come to this last annotated parse tree. Calculated to draw annotated parse tree from bottom. See, S tends to En. How we go for bottom up level? See, you need to draw for your own sake. You draw the parse tree also for your own way. Plus 3 plus 4 and then 5 star 5 plus C. You draw 2 different plus symbol consisting of 2 nodes and multiply with the particular one. So here only same thing they are written. First we have a S tends to En. First grammar production, S tends to En. E, and then how we're going to obtain this value. So this is the bottom up fashion. Don't write the final answer here only. First you calculate. See, 3 plus 4 is what? 7. 7 plus 11, 77. Everyone will know. But directly we can't able to write answer here. First you do the computation. See, E tends to valve. Directly we have E to T is there. E to T from E to T. T in the sense consisting of T star F. Right? This T star F. Later we have to write the T to F. Here also we have a F dot value. F to E they are given. F to E. So again, E consisting of what? E plus T. Write it here, E plus T. Anyhow, you have to multiply. No, anyhow, here also E to F, T to F to E. Here also we have a F to E. Directly we can have a F to E. Here also from T to F, F to E. So we have a productions from T to F, F to E. In every node, we need to add values of attributes at each level. That will be the semantic rules of actions. Then we have a E dot val equals to E dot val plus T, and then E dot val plus T dot val. So add both the sides, left side and right side, add. But before adding, we need to obtain the lexical value, digit dot lexical value. So you go on reach that level, E to T, T to F, wherever F is there in the production only with their given F tends to digit, come to the digit dot lex level, add. Then we need to perform the add. Here also you add those both the left side and then right side productions, multiply T 3 plus 4, 7, 5 into 5 plus 6, 11, 11